Hi guys, and welcome back to my channel. This is episode number 5 of the Coastal Landscapes and Change series over here on my channel. Today we're going to be looking at coastal transport and deposition. I hope you enjoy. The other 4 episodes are already in a playlist linked down below or up here or somewhere on my channel. Go watch them, share them with a friend. I'm making these videos because it's exactly what I wanted whilst I was doing my A-levels, and so I just thought I'd make your life a little bit easier and do it for you. So yeah, please do subscribe down below. Let's just get into it. Longshore drift. Most waves approach a beach at an angle, generally from the same direction as the prevailing wind. Along the coast of West Africa, winds blow onshore from the southwest throughout the year. As the waves advance, material is carried up the beach at an angle. The backwash then pulls material down the beach at right angles to the shore. The net effect of the movement of sediment up and down the beach is a lateral shift. This process is known as longshore drift. Where the removal of sediment is greater than the supply of new sediment, the beach is eroded. Strong prevailing southwesterly winds and large waves create significant and sustained longshore drift in West Africa. As a result, a huge amount of sand is transported along the coast, from Ghana eastwards to Togo and Benin. However, despite that, not enough sand is deposited to replace the transport by longshore drift, so Benin's coastline is still being eroded at a rapid rate. Tides and currents. The angle at which waves approach a beach is also a major factor in coastal sediment transport. However, tides and currents also affect the process of longshore drift. Tides are changes in the water level of seas and oceans, caused by the gravitational pull of the moon and, to a lesser extent, the sun. The UK coastline experiences 2 high and 2 low tides a day. The relative difference in height between high and low tides is called the tidal range. A tidal range creates relatively powerful tidal currents as tides rise and fall. Tidal currents can become particularly strong and fast in estuaries and narrow channels, and are important in transporting sediment. Marine sediment can be transported in 4 main ways. You've got traction, which are where relatively large, heavy rocks are rolled along the seabed. You've also got siltation as your second, where smaller, lighter rocks almost bounce along the seabed. Lighter sediment is carried in suspension, and dissolved sediment is carried in solution. Coastal depositional landforms. Deposition occurs along a coast when waves no longer have enough energy to transport the sediment. Depending on how and where the sediment is deposited, a variety of landforms can be produced. Spits. A spit is a long, narrow feature made of sand or shingle which extends from the land into the sea, or partway across from an estuary. Spits form on drift-aligned beaches. Sand or shingle is moved along the coast by longshore drift, but if the coastline suddenly changes direction because of a river estuary, for example, sediment will be built up across the estuary mouth and a spit will start to form. The outward flow of the river associated with the estuary will prevent a spit from extending right across the estuary. The end of the spit will also begin to curve around, as wave refraction carries material round into a more sheltered water behind the spit. This is known as a recurved spit. The entrance to Poole Harbour is unusual in that it has 2 spits extending both from the northern and southern ends of the bay, forming a double spit. A salt marsh may develop behind a spit where finer sediment settles and begins to colonise salt-tolerant plants. Different types of beaches. Beaches are commonly found in bays. Wave refraction creates low energy environments, which then leads to deposition. A beach could consist of either sand or shingle, depending on factors like the nature of the sediment and the power of the waves. Beaches can also be swash-aligned or drift-aligned. Sediment may be graded along drift-aligned beaches. Finer shingle particles are likely to be carried further by longshore drift, and also become increasingly rounded as they move. Offshore bars. Offshore bars, also known as sandbars, or particularly exposed ridges of sand or coarse sediment, created by waves offshore from the coast. Destructive waves erode sand from the beach with their strong backwash and deposit it as offshore bars. Barrier beaches or bars. Where a beach or spit extends across a bay to join two headlands, it forms a barrier beach or bar, such as Low Bar in Cornwall and Start Bay in Devon. The barrier beach at Start Bay is 9 kilometres long and is formed from rounded shingle deposits, consisting mainly most of flint and quartz gravel. Barrier beaches and bars can also trap water behind them to form lagoons, such as Slapton Lay. Where a beach becomes separated from the mainland, it is referred to as a barrier island. Barrier islands vary in scale and form and are usually sand or shingle features. They are common in areas with low tidal ranges where the offshore coastline is gently sloping. Large-scale barrier islands can be found along the Dutch coast and in North America along the South Texan coast. Tombolos. A tombolo is a beach or ridge of sand or shingle that has formed between a small island and the mainland. Deposition occurs when waves lose their energy and the tombolo begins to build up. Tombolos may be covered at high tide, such as St Ninians in the Shetland Islands and at Lindisfarne in Northumberland. Cuspate forelands. A cuspate foreland is a triangular shaped headland that extends out from the main coastline. It occurs where a coast is exposed to longshore drift from two opposite directions. Sediment is deposited at the point where the two meet, which forms a natural triangular shape as it builds up. As vegetation begins to grow on the deposited sediment, it helps to stabilise the landform and protect it from storms that could erode it. Cuspate forelands may be small, extending out from the coast for just a few metres, or they could be larger features, extend up to 3 miles out from the coastline. Dugganess in Kent is an example of a cuspate foreland. It has a pebble beach and an area of marshland. Dugganess has built up slowly since the first lighthouse was built there in the 17th century. Since then, several replacement lighthouses have had to have been built, as the point of land has grown further out into the sea. Stabilising depositional landforms. Many depositional landforms contain sand or shingle, loose, unstable sediment that can easily be eroded and transported. Sandy beaches may be backed by sand dunes, like those in Studland in Dorset, which consist of sand that has been blown off beaches by onshore winds. Dunes can develop where sand is initially trapped by debris towards the back of a beach. Vegetation helps to stabilise these dunes as a result of plant succession. Salt marshes. Salt marshes are areas of flat, silty sediment that accumulate around estuaries or lagoons. They develop in sheltered areas where deposition occurs, and in where salt and freshwater meet, also where there are no strong tides or currents to prevent sediment deposition and accumulation. Salt marshes are covered at high tide and exposed at low tide. They are common around the coast of Britain. Sediment cells. Sediment moves along the coast in sediment cells. Within each cell, the sediment moves between the beaches, cliffs and sea through the processes of erosion, transport and deposition. Any action taken in one place has an impact elsewhere in the cell. Each cell operates between physical barriers that prevent the sediment from moving any further along the coast, such as major headlines or estuaries. The coastline of England and Wales is divided up into 11 major sediment cells. The sediment cell as a system. Sediment cells act as systems with sources, transfers or flows and sinks. Larger sediment is not transferred between cells, but finer sediment in suspension out at sea can be transferred. The amount of sediment available within a sediment cell is called the sediment budget. Within each cell, depositional features build up which are in line or equilibrium with the amount of sediment available. If the sediment budget falls, however, waves continue to transport sediment and erosion therefore may increase in some areas, because the sea has surplus energy. One change has led to another change, known as positive feedback. However, if the sediment budget increases, more deposition is likely. The sea corrects itself because it can only carry so much, and any surplus is deposited. This is known as negative feedback. The sea returns to a situation where it can handle sediment supply. The way in which the systems attempt to balance is known as dynamic equilibrium. Each major sediment cell can be divided into a number of cells. One of these lie in Christchurch Bay. Within this subcell, the processes of erosion, transport and deposition are all interlinked. Areas of deposition, like Dolphin Bank, form potential sources for sediment as well as sinks. And that is the end of episode number 5 of this series, I guess. If you would like the rest of the series is up there if you want to watch it. Please do subscribe down below. Next week we're going to be looking at weathering and mass movement at the coast, so I hope you stick around for that. Please do subscribe down below if you found this useful. Share it with a friend, share it with your teacher, share it with whoever it's for, share it with them. Yeah, I hope you enjoyed. Please do subscribe down below, and I will see you same time, same place next week, Monday, 4:30 p.m. Bye guys.